Okay, so they're giving me a couple of points like that. So we're in 3.4. We'll go a little ways. We're not going to finish 3.4. We'll go a little ways in 3.4. So they're giving me a couple points, and they want me to find the slope between them. Have you done this before? Do you know about the slope form? We haven't as a class, though, have we? I know some of you might have here or there. We did it, right? I don't think we've done it in here. So let me write out for you the slope form. Does anybody already know it?
y2 minus y1 over x2 minus x1.
Exactly. So the slope formula is y, that's a y, y2 minus y1 over x2 minus x1. That is the slope formula. So that's the slope formula. So remember that slope is rise over run. Remember we've been talking about rise over run. That's what slope is. So it makes sense that the y's are on the top because y has to do with up, down, rise. And the x's are on the bottom because x's go sideways, like running is sideways on the ground, right? So that's the formula for slope. So you're going to want to put that on your 3x5 card. And so now what is that y2, y1, x2, x1 stuff? It's these things. x1, y1, and x2, y2. Is that making sense? So when we say x1, y1, we mean the first points, x and y value. You know, it's always x first, then y, x first, then y, isn't it? So when we say x1, y1, we mean the first points. Those little subscripts are the point number. So the first point's x and y value, and then the second point's x and y value, x2, y2. That's what we're meaning. Okay, so let's plug everything into this slope formula. Now notice the slope formula has subtraction symbols on the top and the bottom already built in, huh? Like that. Okay, so how are we going to go about doing this?
Plug the numbers on.
Yeah, so we're going to go
Minus 9.
y2. So here comes y2, negative 9 right there, right? y2 minus y1. Now, do you see the double negative thing? You know that's going to be positive, right? Because there's the minus from the formula and then the minus from the plug-in, huh? And it's going to be positive, as you know. Then on the bottom it's x2 minus 9 minus x1, which is also negative, so we get the double negative thing again. Good? So far, so good? All right, where does that move us? We have got double negative right here. What's that do? What are two negatives? Positive, you know. So this will become minus 9 plus 10. The bottom will become minus 9 plus 8. And that equals what? 1 over minus 1? Now what's 1 divided by minus 1? Just negative 1, huh? That's our answer. That's the slope. Slope means steepness. We'll show some pictures soon. I don't know if it's tonight or tomorrow night. Well, it won't be tomorrow night. Or Tuesday next time. We'll see what steepness is. Is that good? That calculation? Yeah, slope is steepness. What do they call slope? What do they call slope on a road? I guess they could call it incline. I think there's like people that make roads and develop roads. There's a more official word. The slope of a road is called the grade. Seen the grade? I mean slope. That's just their word slope. On a roof. Anybody worked on roofing? What do they call the slope of a roof? Pitch. Yeah, pitch. I hear somebody say pitch. It's pitch. So anyway, so these are just different words for slope. Those are all steepness. They all mean steepness. Slope means steepness. Call it pitch, call it grade. It's all different forms of steepness. It's all the same thing. That's what we just calculated. We'll get more real with it. So find the slope. Take a look. So slope. Did you guys get 0?
Yes.
Good. y2 minus y1 over x2 minus x1. So this, so we remember this is x1, y1, x2, y2. So it's going to end up being y2, which is 7. And we're going to have the built-in subtraction symbols, top and bottom. So y2 minus y1 over x2 minus x1. Good to there? And so that's just 0 on the top. The bottom, what is minus 7 minus 3? It's minus 10. But 0 over anything, just 0. Right, you good with that? You all know, like if I said, hey, last night I ate 1/10 of the pie. Or no, I ate 0/10 of the pie. So what does that mean? What is 0/10? It's just no pie. It's just a weird way to say I ate no pie, right? All right, so I did. My son took almost the last of it. All right, 0. Is that good? So that slope is just 0. What kind of a line has a 0 slope?
It's the region.
It's completely flat.
Flat.
Flat line. Boy, and we'll get to some pictures. So number 3, they want me to find the slope from those 2 dots. See this dot and this dot? They want me to use those 2 dots to find the slope. You know what I think? You know, we could find the coordinates of this point, find the coordinates of that point, do the whole slope formula thing, but it would be a lot easier to just march off the rise over run, because that is slope also. Remember, so slope, let me make sure we're clear with both things. Where's my pen? Slope is both, you know, slope is 2 things. It's y2 minus y1 over x2 minus x1, or it's rise over run. 2 different ways of saying the same thing. So my point is, we could just start right here, or you could start at the bottom dot. It doesn't matter. I'll show you both ways work. And I'm going to go, you can go right or down, doesn't matter at all. How about I go right? 1, 2, 3, 4, 5, 6, 7, 7, over 7. And then down. Let me go down now. Down 1, 2, 3, 4, 5, 6. Down 6. Over 7, down 6. This is the run, because that's like a person runs sideways, right? And then this is the rise, because it's up, down. So the rise, which one goes in the top of the fraction? Rise, the negative 6 over the run, the positive 7, done. That's the slope. I'm going to redo it. I'm going to start at the bottom point. I'm going to show you that it'll be the same answer however you do it. It doesn't matter. Everybody good with that first way of doing it? Just go over and down. Yeah, let me redo it. Let me redo it now and show you it's going to...
Okay, well.
It's over. It's over. You'll never see it again. It'll be on YouTube. Now, what if I start down here? Because I get that question a lot. It's a good question in different math classes. People go, Mr. Aaron, does it matter? I mean, even some of my pre-calc students often ask, we have some problems like this. Can you start at the other dot? And no, either one. It doesn't matter. So I can start here and I go up 1, 2, and how about I go left instead of up? That'll work. But you just got to remember, as you move around, right is positive, left is negative, huh? Up is positive, down is negative, like you'd naturally expect, right? So as long as you keep that in mind, do whatever you want. It's all going to work. So like I could start by going left. 1, 2, 3, 4, 5, 6, 7. Whoops, there we go. 7 left. Is that good? That was 7 left. And then I can go up 1, 2, 3, 4, 5, 6, up 6. So that is rise 6 over run negative 7. Everybody see what I did there? Is that the same answer? The negative's on the bottom instead of the top. But we've talked about many times that that's the same thing. A negative on the fraction doesn't matter where it is. Top, bottom, out front, whatever. 1 minus is minus. See how that's the same answer? However you want to do it. Just go from one dot to the other. any which way. Just remember, right is positive, left is negative, up is positive, down is negative. Good? Shall we try one?
And that's it.
Right, that's all. That was the whole answer. Yep, that's all they want. All right, let's try that one. So just start at one of those dots. Is that big enough? Here, so this is number 4, I think, right? So slope is rise over run. So if I start at this dot, or you can start at the other one as you saw, it doesn't matter. I'm going to go 1, 2, 3, 4, 5 to the right. That's run, isn't it? So that goes on the bottom. That's sideways, like a person runs on the ground sideways. Okay, and then 1, 2, 3, 4, 5, 6, 7 down. That's rise. That's up, down. There we go. Doesn't matter if that negative's on the top or the bottom, whatever, same thing. Now remember, I remember back when I was in biology years, just a couple years ago, many moons ago, and I got confused. I remember my nice biology teacher saying to me that you count jumps, not lines. So that was helpful to me. Maybe that'd be helpful to some of you guys. So remember, we're counting jumps, not lines. Right? You know what I mean? Now, let me show you what I mean by that. The mistake I was making back when I was in biology is I would like start here. I'd go 1, 2 lines, 3 lines, 4 lines, 5 lines, 6 lines. We're not counting lines, the teacher told me nicely. We're counting jumps, right? So you start here and you jump. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. Count jumps, not lines. And then now we're here, right? 1 jump, 2 jumps, 3, 4, 5, 6, 7. So down 7, over 5. We're counting jumps, not lines. Good on that? So now we're going to talk about slope based on what it looks like. Just based on the simple look of it. In fact, let me just give you a little information. So if a line goes like that, what kind of slope is that? That slope is what? Positive or negative? Positive. Or is it negative? Does that line go up or does that line go down? Yeah, good answer, Karina. It's actually both, right? If you're a person walking on the mountain, if you're going that way, you're going down. But if you're going that way, you're going up. So it's kind of a funny question I'm asking. Is that line going up or down? It's like saying, is that mountain going up or down? Well, it depends which way you're going, right? So which way are we always going? To the right, exactly. So we always mean as you go to the right. That's what we always mean. Otherwise, we'd have no way of saying which one's up or down. Yeah, so as you go to the right, that one's going up, huh? So we call that a line with a positive slope. And then, let me go over here. So a line that looks like that slope is negative, huh? That slope is negative. It's going down. Now, let me put a couple of lines here. What about if we have one line like this, and then another line like that? Which one's steeper? The blue one. So they're both positive. Slope larger. So the blue slope is bigger. It's steeper, right? So you'd have a higher slope, steeper line. All right. So then with that in mind, let's go back and answer question 5. So look at the blue, look at the red. You tell me, let's start with, line 1 is the blue. We'll start with the blue. So is the slope of the blue line positive or negative? Positive, because as you go to the right, it goes up. And is the slope of the red line positive or negative? Negative, because as you go to the right, it goes down. So which one has the greater slope? Line 1 or line 2?
Line 1.
Line 1, the blue one. Because it's positive. Positive is bigger than negative. Good so far? Okay, so now find the slope line. So if we have y equals 4x minus 2, what's the slope of that line? Yeah, but I mean, what's the actual number? Like, what's the... Yeah. Yeah, you all aware that this is the slope?
4.
Right there. Well, just 4. You don't have to say... I mean, 4 over 1 is true, but, 4... Nobody would answer... 4 over 1 just means 4, right? Nobody leaves the 1 in the bottom. That's considered unsimplified. Well, I'm probably confusing you. We're not trying to graph it right now. We would use the 1 if we were trying to actually go up and over and make a picture. But they're not asking us for a picture. They're just saying, give me the number. So you don't give them 4 over 1 because that's considered unsimplified. You just say 4. Do you know what I mean by that? So the answer is 4, even though it's the same as 4 over 1. So the slope is the number right next to x, isn't it? Try number 7 then. They're asking for the slope of that one. So we don't care about anything else. We don't care about the -2. Who cares? It's just the number next to x. That's the slope.
Number 7 is 5 then.
Right. There's one little trick. So I'm not really saying the truth. I like to lie to you every now and then. When I say the slope is just the number next to x, really I'm lying the way most of the skillful liars lie. And that is, just leave a little bit of the truth out. I didn't say anything untrue. I just left some of the truth out, which is really bad. So what did I leave out? Is the slope the number next to x? Well, yes, if you first get y alone. After you first get y alone. Yeah, so that's why in number 7 you got to get y alone first. Number 6 it already was alone. So it was all good. So let me write that out. So it's just like graphing the way we used to graph before today's method. Get y alone. Slope is then the fraction next to x. Are we good? Get y alone. I wrote in. Slope is then the fraction next to x. So you got to get y alone first. So in this equation, number 7, the 5x plus y, I'll make that a little bigger. So 5x plus y is 6, is that what it was? Yeah. So get y alone. Slope is next to x. So if I get y alone, what do I do to get y alone here?
Make it negative.
Subtract 5x. So y is minus 5x plus 6. So what's the slope? Slope is minus 5. Is that good? That's because it's just y equals mx plus b, huh? Have I said that part before? It's rise over run. It's how we graphed last time. Okay, so try number 8 there. They want you to find the slope. I should write the instructions there. So they're saying, find the slope. Okay, so we got to get y alone, right? Getting the slope is always getting y alone. So here's the wall. Y is saying I want to be alone. So we add 3x to both sides. Boom. Minus 2y is 3x minus 6. We're good to there. And now, how do we finish getting y alone?
Dividing by.
And when we divide, remember what we do on the last division? We always divide by exactly what's next to y. Same sign, same everything, huh? So I'm going to divide through by -2. All the way through. You tracking with me? Exactly what's next to y. Same sign, same everything. So y equals 3 over -2x. And then what's negative over negative? Well, who cares? We don't care about what's out there. All we care about is the slope, which is right here, isn't it? All we care about is, we get y alone, and the slope will be next to x. So the slope is 3 over -2. If you have the 3 on the top, that's fine. Remember, it doesn't matter, top or bottom. It's all the same thing.
You mean the negatives?
Carlos. Oh, did I say something? Yeah, I meant the negative. What did I say? The 3, yeah, no, that matters. Huh? Yeah, if the negative's top or bottom, it's the same answer. Carlos.
So on the previous one,
Safe. We good? Does that make sense? On that? Okay, so find the slope. Let's try that one. So find the slope of that thing. Okay, so what do we do to find the slope here? Divide the 4, because we just got to get y alone, right? Find the slope. Get y alone, so boom. X over 4. So what's the slope going to be? Good. We good with that? So it's not just 4, is it? The slope, there's an invisible 1 on the top, huh? So the slope is 1/4. We good? It's making sense? All is well? All right. All right, so find the slope of that one. Try that one, which means get y alone. Okay, so get y alone. So to get y alone, I'm going to add 2x. Have you all noticed that whenever we add subtract the opposite sign, but when we divide by the very same sign, don't we? You seen that? So these go away, and I get minus 9y is 2x plus 7. And then how do I get y alone? Divide. See, I divide by the very same sign, don't I? When I divide. And those are gone. Y equals 2 over minus 9x. And who even cares about that back part? All we care about is the fraction next to x. The slope is 2 over minus 9. You can put the minus on the top or the bottom. It doesn't matter. If I was doing a picture, I'd put them on the top because that's easier. I'd put that minus on the top if I was doing a picture. We good? It's making sense? Questions? Okay, so do you know anything about parallel and perpendicular lines? Let's before we do that problem, we better talk about it. What do parallel lines look like? Yeah, it'd be like that, huh? It'd be like two streets that go the same direction. Right? Parallel streets.
They don't touch.
Right? Parallel lines. And then what about perpendicular lines? Yeah. Perpendicular lines. Yeah, that would be like this direction and that direction. They meet at what? What kind of angle? 90. You ever seen the little box? That means 90 degrees, like a T, right? So at a normal intersection, those are perpendicular lines. They meet like a T. They meet, they cross at 90 degrees. So that's perpendicular. Now, that's what they look like. Now, what do we know about their slopes? What are the slopes like? You tell me, just look at the picture. What do you think about how steep these two red lines are? Are they same, different? Same. Yeah, they're the same steepness, aren't they? Parallel lines have to have the same steepness, so their slopes are equal, aren't they? Parallel lines have to have equal slopes, same slopes. Okay, so for example, if one of them is 2/3, the other is also 2/3. They're the same. Now perpendicular, what do you think about perpendicular lines? What do you think about their slopes? Does anybody seen this before? It's going to be a little bit more of a tricky point.
Be like a mirroring.
Yeah, something like that. So what if one of them, let me start with the 2/3 thing again. What if,
Your
so
reflection in the mirror?
2/3 and what would be the other slope? 3/2?
3/2.
Negative. Good. That's what it is. It's opposite sine and opposite upside down. Both. Everything is opposite. Sine and fraction. Both opposite. So perpendicular lines, let me write a note for you to that effect. Perpendicular lines, slopes are upside down. We call that reciprocal. Upside down and opposite sine. It's upside down and opposite sine. Both. Like everything's opposite for perpendicular lines. So that'd be like 2/3 and -3/2. Let's do another one. How about if I started with negative 5/7? What would be the other one?
7/5.
Positive, regular, 7/5. Right. What if the first one was -6? What would be the other one?
1/6.
Positive 1/6, because 1/6 is upside down of 6, huh? You with me? Is that making sense? Right, because bless you. A plane, a 6, a -6, that's understood to be invisibly over 1, huh? So flipping it, 1/6. I don't know if you can read that now then. Is that good? So that's parallel and perpendicular lines. Determine whether the two lines are parallel, perpendicular, or neither. Are these lines parallel, perpendicular, or neither? Give you a second. See if you can figure out if those two lines are parallel, perpendicular, or neither. Yeah, so now the slope is right next to x. I don't even care about that 8 at all, right? It's not important to me. I'm just looking at slopes. I'm just looking at the fraction next to x. By the way, notice y is alone. If y wasn't alone, those would not be the slopes, right? I'd have to first get y alone. But y is already alone, so those are the slopes. So one of the slopes is 2/5. The other is -2/5. So are they parallel, first off? Are they exactly the same? No. No, they're opposite signs. Are they perpendicular? So they're not parallel. Are they perpendicular? To be perpendicular, you got to be completely the opposite. Like upside down, opposite sign, everything opposite. Is everything opposite about them? No, they're opposite sign, but they're not upside down. So it's neither. Now, what does that mean, neither? What would that look like? That'd be like two lines that intersect, but not at 90 degrees. They're not parallel. So it's like weird streets, that kind of go off at a diagonal. They're not parallel, and they're also not like a normal intersection. They make a weird intersection. I don't know, are there any streets like that around here? It's cool. Okay. All right. All right, is that good? We'll try number 12. So here I'll write those in fact, let me just rewrite it. That's not very good. 3y plus 2. And the other one is -8x plus 6y equals 2. Okay, so they want to know, are these parallel, perpendicular, or neither? That's the question. Okay, so how are we going to answer this question? What do we got to do?
Get y alone in both.
Y alone in both. Good. Let's see here. So I'm going to do them one at a time. I'll move this over. So we got to get y alone, right? Got to get y alone. So I'm going to, what am I do? I'm going to subtract 2x from both sides. So then what do we get? 4x minus 2 is 3y. Last step to get y alone. Divide through by 3. Boom. So what's the slope on that one? It's that 4/3, isn't it? Everybody good with that one for starters? So you just get y alone. The fraction next to x is the slope. I don't even care about the other part. I don't even care about the -2/3 at all. Just because right now I'm just talking slopes, right? So let's get y alone. The fraction next to x will be the slope. Guaranteed. So, okay, now let's take the other one, which I erased, so I don't remember. What was the other one? Minus 8x plus 6y is 2. Okay, so the other one, minus 8, I forgot already. Minus 8x plus 6y is 2. Minus 8x plus 6y is 2. Okay, so we're supposed to solve for y in this one, right? Get y alone. So to get y alone, I am going to add 8x to both sides. And so that'll be 8x plus 2. And what's the last step to get y alone there? Divide by 6. All the way across. Whenever you divide by all three. Although I really don't care about that other number out there. So what do I have now? I have y equals. Now, what do we do with 8/6? Simplify. What goes into 8 and 6? 2. Divide by 2, top and bottom, makes it 4/3. And I don't even care, blah, 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 whatever, about the other part. So 4/3 is the slope for both. What does that mean about these lines? Parallel lines, because their slopes are the same. Is that making sense on that? Everybody good with how I get I get y alone on that. How you doing on that? Are you good? Are you able to do what we did? So if you're having trouble, I think Shelby's available. She'd be a great help. Go by her hours. Anybody in the tutoring center would be helpful. Shelby's going to be the most helpful because she's not going to show you a different way. You know how that happens sometimes with tutors? Go to a tutor and they don't know. They're not in your class, so they just show you the way they know. And that can make it worse than if you'd ever gone because now you're doubly confused. So Shelby would be the most helpful. She'll show you the same exact way. But get the help you need on that. Now, we did not finish this section. We didn't meet.